Hello friends, I'm Amruta and welcome to my channel Learn Simply with Amruta. Today I am with a brand new video from our list, that is number theory. That uh, The video is about GCD and LCM of two numbers. So today we will first learn GCD of two numbers. If you like this video, please share and subscribe to my channel. Yes, so let us go to the first slide. First of all, we will try to understand what is GCD. And I guess you know what is the long form of GCD, that is greatest common divisor, right? So today we will see what is this GCD and how to write an algorithm for calculating GCD of two numbers. So let us move to the slide now. Yes, you can you read it properly. Puzzle. So for you, here I am having a puzzle, and puzzle is regarding the previous video. And if you have not seen the previous video of prime numbers, a link is available in the description box. Please see the first of all, please see the video of prime numbers and then try to solve this puzzle. So what is the puzzle? Suppose we take first n prime numbers. So n means the prime numbers. Whatever numbers, how many numbers you want to take, you just take those prime numbers. If you want to take first 10 prime numbers, you can take, multiply them all together, all the prime numbers, and after multiplication, whatever result you will get, then add 1 into that. Okay, after adding whatever number you will get, first of all check that number is a prime number or not, and if it is a prime number, give a counter proof or proof with one example, right? So solve this puzzle and please give me the answer for this puzzle in a chat box. So let us move towards our the topic. Topic is greatest common divisor. Now before understanding the greatest common divisor, first of all you should know the concept of divisibility. So what is this concept of divisibility? It is very simple. As you have learned, this divisibility means, here we have I have taken one example as a divide b. So what is this a divide b? Where a is your divisor. Okay, I'm sorry, a is b is dividend, a is divisor, and whatever result you will get out of this, that will be your quotient, and then you will get remainder. Okay, so we will represent it as a r. So it is denoted as a divide b, and it is considered as a divide b gives the answer. We can represent the same thing in different format. The format is a equal to b into q. Okay, so that is the another representation of same thing. So I guess this is very easy and you know it. So we will move further. The smallest natural divisor of every non-zero integer is 1, and this thing we have seen in prime numbers as well. The smallest divisor from all the number series is always 1, because we don't consider 0, because 0 gives you answer as 0. So the smallest divisor is 1. Now what is greatest common divisor? So the greatest common divisor, which is also called as the greatest common factor, because now here we are dealing with the factors of two numbers in the, is the largest number that divides them both. Now here we are going to find out the common divisor, and that divisor has to be the largest number. Okay, largest number from the list of divisors, right? For example, just you take 20 and 15. I have two numbers 20 and 15. So if I'll take 20, so what are all the divisors of 20? So what are all divisors of 20? Just list down here. 1, yes, 1 is the divisor. 2, 3 is the divisor, no. 4 is the divisor, yes. 5 is the divisor, yes. 6, no. 7, no. 8, no. 9, that is also no. 10, and then number itself, 20. Okay, we have listed all the divisors of 20. In same way, just list out all the divisors of 15. So what are the divisors? 1, yes. 2, no, because it is not an even number. So 3, yes, 3 is a divisor. Then 4, no. For 5, yes, 5 is a divisor. 6, no. 7, 8, 9, 10, no. Directly 15. Okay, so these are the divisors of 15. Now what we need to find out, the greatest common divisor. Greatest, not smallest. Smallest common divisor is 1. That is for all the numbers. But if we talk about greatest common divisor, then 2, 3. No. Here 2, 3, 4, these are not common divisors. Directly 5. 5 is a common divisor for 20 as well as 15. So now we can say 5 is the greatest common divisor for 20 and 15. Correct. So this is how we calculated the GCD, right? This is very simple, but moving further, we will see how to calculate GCD by using some pseudocode, because in this series we are learning how to write an algorithm, how to write a pseudocode, and how to evaluate, execute that particular pseudocode for the computer. Okay. So traditionally, as you know, we represent GCD as GCD of a comma b. If I'll write for this two numbers, GCD of 20 comma 15. This is the way of representing GCD of two numbers. Yes, so the same another example we are looking out here, that is find the greatest common divisor of 30 and 36. So whatever the task I have done here, the same task we are going to do here. We are going to find out all the divisors of 30, then all the divisors of 36, and then find out the largest number which appears in this list, and that should be common, right? Yes, 1 is common. Yes, but it is smallest. 2 is common. Yes, but still we will try to find out further largest number. 3 is common. Yes. 5, 4, no. 6 is common. Yes. Then again check into the list. No, there are not common numbers. Now the greatest common number is 6. So the greatest largest number which appear to be the GCD is 6 for 30 and 36, right? So how to do this mathematically, because here we have seen in very simple way, right? So mathematically, if we talk about the Euclid's algorithm, here we have Euclid's algorithm to find out the GCD of two numbers, and with the help of this Euclid's algorithm we are going to write a pseudocode, and then we are going to find out a GCD. So how this Euclid algorithm works, okay, so that we will see. First of all, I will show you in a mathematical way. I'll take example as find out the GCD of 54 and 24, two numbers. Okay, find out the GCD of 54 and 24. So what Euclid algorithm says? So Euclid algorithm says if this is A and this is B, then take a GCD of A comma B such that divide this A by B. This is A and this is B. Try to divide A and B. Okay. So just check key 24 divides 54. How it is being divided? So here 24 2s are 48 and the remainder is 6 and the division is 2. We are not bothering about the division here. We are interested in the remainder only. Now we got 6 here, but it is a remainder, and what Euclid algorithm says that you need to divide these numbers until you get 0 as a remainder. Please try to understand, you need to divide these two numbers until you get 0. So if you got the logic is Here you are going to use recursion. Correct? You guessed it correct. You are going to use recursion. So now this is remainder, and until we get 0 we are going to divide it. So now what is A and what is B now? Because already we used A and B here. So now A and B are getting changed. So now this 6 is new B for further calculation. And how we got this new B? We got this new B as A mod B, right? Now what is A for this calculation? So A is simply take this 24 from here and put here. So this is your new A. Okay, now once again divide. So what is the division? 6 4s are 24, and now we get the remainder as 0. So we are not interested in the quotient, we are interested in the remainder. So remainder is 0, and as I told you, what Euclid algorithm says, when you get 0, stop there, right? And now whatever B was there, now this is your GCD. Okay, this is your GCD of two numbers, that is 54 and 24, right? So this is how we solve the Euclidean's algorithm. Now in simple way, what this algorithm says, I'll write here. Okay, whatever I have written here, I'll write in a simple way. GCD of A comma B is equal to, how we calculated the GCD? GCD of A comma A mod B, right? Now just remember, this is the logic, this is the formula to find out or to calculate the GCD of A comma A mod B, and that too using recursion. You are going to use recursion over here. Okay, now once you do this, until you get any one number as 0, such as any one out of A and B as 0, until you get 0 you are going to do the same practice. Okay, so I'll write here the same thing, GCD of 0 comma B. If it is so, then your GCD will be B, and if you go with GCD of A comma 0, then GCD is A. This is the Euclid's algorithm. Now the same steps I have written here in algorithmic format. Let us consider A and B are the two numbers for which we are going to find out the GCD. Then find out A mod B, and which will be the R. So just change those things. A equal to, now your A will be this B and your remainder will be new B. Okay, and repeat this step until you get 0 as a remainder. Okay, and as you get 0 remainder, your GCD will be B. There you need to stop. So just look at the pseudocode. With the pseudocode you will understand easily. GCD of two numbers A and B. Here we are using recursion, as I told you. Until you get 0 as a remainder as a B, you need to continuously execute the same code, such as GCD of B comma A mod B. Okay, GCD of B comma A mod B is in continuation, and as you get 0, stop there and your GCD will be B. Else, if it is not the situation, your GCD will be A, right? So the same thing I have executed, I have shown you here, right? And for that, this is the pseudocode. So this is all about the GCD of two numbers. If you like this video, please hit the like button and please share this video with all your friends. Thank you so much.